Welcome to the Electrical Engineering Laboratory. We created our multimedia e-learning system for your learning enjoyment, and hopefully, to teach you safe practices in and around electrical laboratories. You may safely practice real-life experiments by doing and trying, without the risk of being electrocuted. The course consists of DC circuit experiments. Starting from Ohm's law, we introduce you step by step to electrical circuit theory. This program is an interactive training course, which allows you to experiment without harming yourself or damaging any equipment. In the simulation of each experiment, you can explore the behavior of the given circuit by yourself. We have built a mathematical simulation for each circuit included in the course. You may observe the electrical equipment as you see it in an electrical engineering laboratory. The list and the order of experiments have been carefully planned, and we recommend that you conduct these experiments in the order arranged for you. We have prepared material for a systematic and meaningful growth of your knowledge, rather than flooding you with trivia on electrical engineering theory. As a first step, from the main menu choose an experiment you would like to conduct. The main menu contains a list of available experiments. You can scroll up and down the list. Let's choose experiment number 3, Kirchhoff's current law. Now you are in an experiment menu. On this screen, you have a few options related to the learning module. If you are not familiar with an experiment, we recommend that you listen to the lesson before entering the laboratory. The lesson explains theoretical aspects of the circuit, shows the layout from different points of view, and takes you through a review of cable connection. You are familiarized with the components of the circuit which are interactive, and how you can manipulate them. After listening to the experiment lesson, you should have a clear vision of the experiment and measurements available in the presented. You have now returned to the experiment menu. To enter a circuit simulation, you should tap the simulation button. In the lesson, you have been familiarized with an aspect of circuit theory, which you can explore in depth in the laboratory simulation. There are common components for all simulations. You can see the front of the equipment displayed. You can manipulate each component of the circuit by tapping on it or dragging its adjustment sliders. For example, by tapping on a multimeter, you activate a pop-up window displaying the additional functionality of that multimeter. If the window obstructs part of the view, you can drag it to a different location. Just tap and drag the window title bar. Although each element of the circuit has a different functionality and appearance, icons associated with their dialog windows have the same meaning. This icon, combined with a component symbol, means that you can interact with the component. In the case of the multimeter, you can change its range by tapping the range value. This icon, combined with a component symbol, means that you can replace a component with an alternative component of the same type. In the case of the multimeter, you can replace it with another multimeter built for a different range of measurements. You may browse through available equipment by tapping the browse icons. To select a new multimeter, tap the checkbox. If you tap this icon, you can see the circuit diagram and location of related circuit components on the main screen. Tapping on this icon lets you obtain information about the currently selected circuit component. Some circuit components such as the voltage supply or the variable resistor have a slider that allows you to adjust its value. You can tap and drag the slider in the main window, or in the pop-up window. The pop-up window dragging and tapping functions may become very convenient if you have a problem selecting the slider in the main area. The main circuit breaker is located in the upper left corner of the screen. It can switch on or off the power delivered to the workbench. You can switch the main circuit breaker on and off by tapping on it. The icon bar displayed on the left-hand side of the screen, below the main circuit breaker, consists of several icons. At any time during the simulation, you can collect the display data by selecting this button. If you want to delete the collected data, tap on the Erase button. One of the available tasks is the ability to glance over the circuit layout. Tapping the button with the circuit diagram icon reveals a pop-up window with the circuit diagram of the current simulation and the location of equipment in the main screen area. During the simulation, you can modify each component of the circuit by changing its settings or replacing it with a component of different characteristics. However, if you decide to reset the simulation to its initial conditions, select this button. Tapping this icon gives you quick access to the introduction of the current experiment. If you collected some data during an experiment simulation, you could view it by selecting this icon located in the simulation toolbar. In the following results screen you will find a table holding numerical values of the collected data. You will be able to build graphs displaying this data. Tap this button if you want to build a graph that represents relationship between any data collected. Initially an empty graph appears. Tap on the Edit Graph icon to enter the graph editing mode. By dragging and dropping headers of the result table you design a graph. Type in the graph title in the area provided. When you are happy with your design, select the Graph OK button. Now you can see a graphical interpretation of the data collected. Tap this icon if you want to remove a graph. If you are not sure about the results header meaning, select the circuit diagram button and you will see wherein the measurements were taken. To close the diagram, select this icon. After returning to an experiment simulation, you can continue collecting data, and the results table and graphs will be updated automatically. Each experiment has test questions. Many of these questions have randomly generated numerical values, so every time you enter the same question the numerical answer will be different. Every question has a feedback that explains the correct answer. Our goal is to teach, not to examine you, so you can practice as much as you wish. No one can be electrocuted in this program version, but simulations of incidents, resulting from wrong circuit settings, have been included in the simulation scenarios, to make the laboratory experience more realistic. Have fun exploring electrical circuits while using our application.